This is a Redodo 12 volt lithium battery. And yes, it's pronounced Redodo. They emailed us and told us. This video is sponsored by Redodo. They sent us this battery, they gave us a choice, and I'll give you some specs on this a little bit later in the video on why we chose this particular model, but it is gonna run the 12 volt system in the van. We're gonna install it today before we get the battery in. I've gotta tie up some loose ends on the wiring in the van.
Shorter of those screws, and
yeah, and those screws are really unforgiving. They strip out really easily.
Should I?
Just be real gentle with them is all. Okay.
So these,
the big chunkers need to get connected back up over there. And there's no slack. There's no slack to do it. Okay.
if you want to get wedged up there.
Yeah, once I'm stuck, I'll be up here and pissed off. It's not gonna reach. We're not gonna be able to do it. I can't get it. It's not gonna reach.
It's gonna reach.
It's not gonna reach.
It's gonna.
It's amazing how good copper wiring is as a conductor, because the wire's getting hot in my hand up here, you know.
What's that go to? The pump?
This goes to the pump.
This is our water pump. So if the water pump's on,
Tip of that's super hot.
and we start a fire.
I think we're okay, actually. End it up.
So there we go. Drop. Just need to find a little scrap to cover that hole.
Yeah, I'll just put a piece of.
Or maybe that's your phone pocket.
Yeah, I was gonna make a phone holder.
And you just give it a back.
Mm-hmm. I was just gonna screw it right there.
Perfect. That's fun.
Mm-hmm. People will think it's like purely a phone holder,
We'll never know.
but
there's
it's
a secret
actually a
hole.
freaking hole cover.
Well, you all know.
If you've been following our build series, you probably know that we did a pretty major layout change about halfway through this process. We were originally going to have a slide out bed from the side, and instead we went with this high bed with the garage under it that slides out to the front. And ultimately it was the best thing for our layout. We're really happy we made that decision. What we're doing with the wiring over here is actually overcoming some of the original planning that we had when the layout changed to change things. I was gonna put a switch bank over here for switching on and off the water pump. It's a 3-switch bank. But I got to thinking about it when we put our fridge in. It's hardwired to our electrical system, but I actually do want to be able to switch that off and on. If I need to turn the fridge off because we're not using it, you know, or I need to pull it out or do maintenance on it, I wanted to have that on switched power. So the power for the fridge is on this side, the power for the water pump's on this side, but it all comes together over on the driver's side of the van, and that's where our electrical panel is going to go. So what we're doing is basically reworking the wiring over here where I cut it to put a switch, joining that all back together so that I can put the switch on this side. And that's gonna let me run the water pump off one of the switches, but also put a switch for the fridge. Our overhead cabinet bank ended up on this side of the van. If we end up doing some under cabinet lighting, we'll have a third switch available in that switch bank for us. So a little bit of rework, and you know, it is what it is. If I could change anything about the order of operations of how we built this thing, I definitely would have had the electrical panel installed before this bed was in. But originally the electrical panel was gonna go further forward, but now I get to install that panel in this cozy, convenient space that I can't really fit into. This is the box that we're going to be installing for our electrical panel. It is a combined 120 volt AC and 12 volt DC panel with a fuse block on this side. I've been rolling with a temporary panel that I'll show you in just a second for our 12 volt. So I got to reroute all of our wiring into this box, and I've also got to build a frame for this box so that it's up and off the ground and I can easily get in there and wire it. I guess first things first, I need to go ahead and get this put in place. And I've just been using this temporary fuse block to power our lights and fan while I'm working in the van. So this is going to come out, this wiring is going to get cleaned up and all get terminated. And then this is our shore power wire that we're going to future proof with. Everything I'm doing is future proof. And then over in this corner, the very back of the van, I left this wall studded out with nothing on it. And the plan is to simplify our wiring I'm going to have a 1/2 inch piece of plywood that fills this space that I can actually unscrew and take off and screw down and mount all of our components to it. And then once everything's laid out really nice and wired together, I can screw it to the wall, and then we're just going to wire the battery straight into it and be good to go. So it's going to make our wiring job really simple, and again, future-proof for us to add other stuff to the system. There's very little of this bed that I built out of 2x4s, but I think holding the bed up and holding our electrical box in place are some places to splurge on weight. I'm hoping to be able to put this stud in place with just enough room to slide the battery behind it. Yes, that's gonna be awesome. Nice and compact, love it. Pocket holes are a lifesaver on van builds. Need another inch. That'll do it. That's perfect, very snug. And she fits. Love it. Let's talk a little bit about this battery. So this is it's a 12-volt lithium battery, and it is actually the model that they sell. It's their trolling motor battery. There's two reasons why I picked this one for our van. This particular battery has a low temperature cutoff. That's really important because lithium batteries, you're not supposed to charge them when it's below freezing. It's bad, it damages the battery. This battery management system will actually cut off charging if it gets below freezing. That's really important in a vehicle application. The other reason why I chose it, these are made to be like an automotive drop-in replacement. So this is a Group 31, which is just the size and form factor. It happens to be the exact same size battery that we have two of in the RV. So one day, if we ever want to move this to the RV and do a lithium conversion, this would fit perfectly. It's 100 amp hours, which for us is a ton of power. We're pretty power conscious when we're on the road. This is actually going to give us the same amount of capacity as we have in our RV in one battery instead of two. And that's because in the RV, we have AGM batteries. They're lead acid. You're not supposed to discharge them below 50%. This you can discharge almost all the way down. We're wiring it up just for our 12-volt system. So it's going to be running our water pump, our refrigerator, our lights, ventilation fan, and a handful of, car sockets, USB chargers, and things like that. At this time, we're not planning on running an inverter off of this, although you certainly could. Now, this thing's got really impressive specs for where it is. It's a very affordable battery compared to some of the other ones on the market. It is IP65 waterproof. It's dust resistant, so it's gonna be really good for a rig like ours. And there's some really great videos out there where people like open these up and tear them down. I had a lot of confidence doing my research on this battery that they're well made on the inside, and the battery management system's really good on it. That's what you want in a good lithium battery. You just don't want something that, if it gets mishandled or you don't set your charge parameters right, you run a risk. This one, I feel really confident in. They seem to be really, really well made. So it automatically cuts off charging when the temperature gets below freezing. It resumes when it gets to 5 degrees Celsius. So about 40 degrees, 42 degrees Fahrenheit. It's dust proof, moisture proof. I've seen in the teardown videos, there's actually a lot of foam padding in here, so I think it's pretty good for vibration. And it's salt spray resistant to prevent corrosion on the terminals. The terminals are nice, rather than automotive grade terminals, which we had to adapt in the RV. These are screw down terminals, so you can get a lot of clamping force and really secure your connections. Talking about the maximum discharge spec, 120 amps for 10 seconds, so 120 amps is 1400 watts. 300 amps for 5 seconds, and it'll do 500 amps for 1 second. So that means, if you've got an inverter that has surge power above its normal capacity to start things like electric motors or blenders, things like that, this thing can totally handle the surge, the startup surge of an electric motor. On one, you could definitely run a 1000 watt inverter. If you wanted to do a 2000 watt or higher inverter, you probably want more than one of these wired up together, but I think it's gonna be perfect for our setup. And of course, this is like the cornerstone of just an expandable system. You can add more and more of these and keep adding capacity. Redodo did send this to us. They asked us to review it, test it out, and try it and show it to you all. They've also offered, you know, I mentioned that these are pretty well priced, they're pretty affordable. They've also offered our viewers a 5% discount, so you can use the link in the video description to get that discount, or you can use the coupon code WILDER. So use discount code WILDER to get 5% off your purchases for these. And if you buy one, like being totally straightforward, it supports the channel, it helps us out a little bit, so we appreciate that. All right. Back to the install. Before we get this box screwed in under there, and it's really hard to get to, I'm gonna pre-wire at least a little bit, whatever I can. I'm gonna do something a little bit unusual with this, which is I'm gonna do my main supply on the AC side with this, like, you know, appliance cord. It's rated for the amount that I would use. You would never do this in a house, but mobile vehicle application, you know, you do what you gotta do. And that's gonna let me plug this in to a like portable battery bank that has a built-in inverter, and that's how we're going to run all of the AC outlets in the van for now. When the time comes that we're ready to put an inverter in, I simply pull this wire out and wire my inverter directly into the main 30 amp supply. I am putting a 30 amp breaker in here. Everything's future proofed. We are pre-wiring. My shore power cord is 30 amp. My main breaker is going to be 30 amp. We'll be able to put an air conditioner in this thing one day if we decide to. I've got a 30 amp shore power cord coming in. Not cord, but you know, Romex. This is marine wire. I'm just going to put a plug on the end of this, and what that means is when we plug into shore power, I'm just going to plug my charger from my portable battery bank into that. That's not really what this video is about, but I wanted you to see like the kind of idea for the whole system here. All of the wire is marine wire, and of course our 12-volt wire, it's all stranded. It's not like solid copper, you know, it's got the little frayed things. So you're gonna see me using these what are called ferrules. These are awesome. It takes, you know, they're cheap, but you need one crimping tool for it, but it's gonna let us crimp it all down and have these solid ends on it. And so you'll see me using those here. I'm just taking the stranded wire and making it really easier to wire it into a breaker or a switch panel like this. One thing that's kind of handy about this box is it actually has an outlet in the back, and it's pre-wired on the ground and neutral side, and you just have to put it into one of your breakers to use that outlet. Now that's made for an RV where you have a plugged in converter that's charging your house batteries. So I may well use that. I'll go ahead and wire it up to a breaker and keep it turned off, and it'll be there if we need it. I'm gonna go ahead and knock out a slot here for this, you know, what is essentially, as far as the panel's concerned, shore power. This bad boy. Okay, and so you just kind of twist the wire, put it into the ferrule like this. Oh yeah, it comes right to the tip. And then this is the crimper tool. You put the end, not the sleeve. Couldn't figure that out for a bit. Crimp. It's on there, solid. Isn't that cool? And it's gonna make wiring this up so freaking easy. For whatever reason, these tapered ones that I got, I don't know if they're all tapered, but it's just like the wire just goes in there. You never get like where the strands get caught and want to bend up on you. You just kind of twist it as it goes on. It's awesome. How cool is that, guys? Put it in. And that's just a super confident connection with that. That's awesome. And so this takes, you know, all three parts of that shore power plug and bonds the neutral bar back to it, the ground bar back to it, and then we're going to put this into our main breaker. And when that hits the main breaker, that's going to light up everything. Oh, this is set up. You could do 50 amp with it, like two different sides of the panel. I'm only going to be using the one, but fits right in. Clamp that it down. Again, super confident connection. Stabs in, it's in there. I'm gonna go ahead and flip this breaker off. I'm not gonna plug this in, but I wanna make sure that, you know, none of this is live until I have the other ends of my plugs wired up. And since this is kind of a small, limited size panel, I did get these double breakers. I didn't mean to get 15, 20. I meant to get double 15s, but we're just gonna go with it. All of my wiring supports 20 amp. My power supply may not, but like, you know, when it comes to fuses and breakers, it's not about what's on the other end of it. If you need 20 amps, you need a 20 amp breaker, but it's because you used a wire that can support 20 amps. This is here to keep the wires from catching on fire if you overdraw the power. I'm wired for 20 amp, even though I don't have 20 amp receptacles. I'm gonna go ahead and put this in, and I'm gonna wire up this guy, which is the outlet on the back here. Let's look at it. It's a 20 amp outlet. Look at that. Did you guys know this? A lot of people don't know this. If it has the slot on the side, it's a 20 amp plug. If the appliance you're using needs 20 amps, it'll actually have a sideways plug right here. So now you know. So we're gonna put that one in 20 amp. That'll actually be my only 20 amp receptacle in the whole rig. Okay, you're on there. You're on there. And the last thing I'm gonna pre-wire is I'm gonna run my supply wire to the 12 volt side of this panel. I'm running 8 gauge wire for this, which is more than enough for all of our appliances, then some. But again, future proofing. There's a lot of fuses on this block, and we've got a lot of battery power with this Redodo battery, so we can push the amps. I'm gonna have the wire to support it. I don't think it can strip wire this big. What's your maximum gauge, buddy? It actually did. Took a couple wires with it, but I can live with that. And then this big wire that's already in there is actually just bonding this ground wire to the ground bar in here. So I just run all my grounds to the bar, and it all comes back to the battery through this one over here. I'm stoked about the layout, so I'm not gonna complain. Nice and sturdy, guys. That's how we do it. I'm gonna spare you all the grunting and literal headbanging of crawling under here and putting all my ferrules in place. I'm gonna do the same thing I did for the AC side, except with all of our DC circuits, wiring them into the DC side of the panel, putting ferrules on the end of it, and I've commandeered Henry's mattress that goes under the bed so that I can be sort of comfortable while I'm doing it. I don't know. All right, so that wasn't too bad. Had my little cushion in there, just got cozy, put on some tunes. Here's what it looks like all wired up. I mentioned this earlier, fuses are for wires, not whatever you have plugged into them. And since all my main DC circuits are 14 gauge wire, it's rated for 15 amps, so I've got 15 amp fuses. Having that sized for your wire means that I can reasonably safely just like tap into one of the circuits in the van if I want to add something later, and confidently know that if I pull too much power across the wire, I'll blow a fuse. Rather than being like, well, I fused that wire because I had a 10 amp load, but I think I can add it, you know what I mean? You won't remember what wires are in there. So, I did have one really sad discovery that I'm bummed about, which is that I have 2 branch circuits for outlets on the AC side of the power system. I've got one pulled through, ready to wire down. The other one is not long enough. It's just not. And it's behind built-in cabinets and all kinds of stuff. My only option is going to be to put a junction box back there and join up another piece of Romex, and I keep saying Romex, it's not Romex, it's marine grade wire, but some what is it, 12.3 that I'm running. I'm gonna have to put another 12.3 extension on that. I hate just adding junctions for no reason, but that's van life. And I also left my 2 slots. I think this is pretty typical on these sort of RV style ones. See, I have the top 2 fuse slots there are empty. That's because those two are rated for 30 amps, which is what 10 gauge wire is rated for as well. And so I will put that 10 gauge circuit off of the 30 amp line, if that makes sense. So I left those open, and I'll have another one available if I need it down the road. Our Redodo battery can certainly supply that kind of amperage, no problem. So I don't have a need for it yet, but I know I'm future proof. A little bit ugly on the back side. I can come back and zip tie that. These are now my main power supply lines to the DC fuse panel, and we're gonna wire that into the battery next. The way we're gonna do it though, so I'm gonna go ahead and cut the board that's gonna get screwed into this wall panel here, and then we're going to mount our fuses, all of our battery connections, all that stuff to the board, pre-wire it all, and then we'll just screw it in and hook the battery up to it. In most cases, I would typically recommend getting all the stuff off your workpiece. That's what we wanted. So now what we're going to do is start laying out this board with all of the different components that need to be wired together. The ideal setup here leaves room for like a solar charge controller and potentially an inverter across the bottom, with an inline fuse for our supply lines, an inline main battery fuse, a battery disconnect, and a couple of bus bars for this all to connect into. So I'm going to fiddle with this for a minute and kind of come up with a bit of a layout. Alright, so here's what I've come up with. It's less than ideal, and the reason why is I had all these terminal connectors from my battery lines, and I didn't realize I didn't have any 0 gauge, which is what I was planning to run as my main supply from the battery. So I'm gonna have to order some of those, and I'll change this a little bit when I get them, because basically everything coming into the bus bars from the battery I will rework with this 1 gauge wire. Jumper wires. This will supply our panel from the negative side. This will supply our panel on the positive side. This is actually a fuse breaker rated for 60 amps. So if we pull 60 amps across, which is, you know, well above the rating of our 8 gauge wire, this will blow. Yeah, so I'm gonna make all my jumpers here, get this all secured to the board, and then we just have to go plug in the battery and screw this in. This is a future thing. This is gonna be disconnect switch for our solar wires. I have the solar wires now, but until I get a solar charge controller, I don't know how it's going to fit or exactly where it's going to go, but this will be in the mix somewhere when we lay that out. And my bus bars are in the middle, where it's really easy to, you know, if we add an alternator charger, you just wire in the positive and the negative. If we add a inverter charger, we just wire in the positive and the negative on the bus bars, and the rest of this just works. I don't have to change anything. So heat gun's putting in work today. All right, well, this is what I got so far all wired up. Notably missing is my big mainline fuse for the battery. That's just as well though. We're pulling very small loads through it. I have a breaker up here, that's the only load that comes out of it. And we're gonna have to replace these lines with 1 gauge wire after I get the right connectors anyway. It also would have been a purely ornamental fuse because it was way too high of an amp rating for these little wires. So, little wires, it's 8 gauge. We're gonna go install this in the van, hook it up to the battery, and see how we did. And now it's time for the Redodo. What size do you take? We're in. I've got the battery disconnect off, by the way. Okay. It's gonna fit right there so perfectly. I love it. Okay, we're all in. Excuse some of the wire mess. These are actually my solar panel wires. They're kind of clogging up the view and I need a little bit better cable management, but we're wired up. Now I'm about to reach in here and flip this battery disconnect switch. And when I do that, one of three things is gonna happen. If I messed up, nothing's gonna happen. If I messed up really bad, we're gonna get magic smoke. And if everything went right, these overhead lights are gonna turn on. Here we go. Oh, I've never even seen this light on before. Look at that. We did it, guys. We are running on lithium batteries. That is so awesome. It's just such a big difference from running on a power bank. I mean, this is a dedicated battery system. It's gonna run the fridge for days and days. We're gonna be able to put solar on it. This is awesome. This is game changing. We never even had lithium in the RV. All those years of traveling, all those big trips we did. This is such an upgrade. And I could tell that's pushing a higher voltage because those lights are brighter. That's awesome. I got one little thing that's been bugging me before we call this a win. And it's these two wires dangling out over here by Henry's seat in the front. That is supposed to be a USB charger so that he can charge his audiobook player or his Nintendo Switch on our long drive days. And so I'm gonna wire that up right now. I'm dying to, it's the only circuit that I haven't tested because I never had anything hooked up to it. So we're gonna test it out. Bam. Oops up. Oh, it lights up. Dude, I gotta see if it charges my phone. It's after midnight, guys. Been late nights on this van. Oh, we're charging. Hell yeah. That's awesome. Well, thank you guys so much for watching. I hope you enjoyed this video. It is such a monumental step in the build, and I cannot say thank you to Redodo enough. This is a really great battery. It's gonna be awesome for us, and they came through really clutch. We're leaving in like 5 days, and we didn't have a lithium battery for this thing, and they reached out and said they wanted to send us one and have us try it, and they expedited it. They got it to us fast. They've been awesome to work with. Really excited to be able to test this thing out. We're gonna be on the road for 3 or 4 weeks, up and down the California coast, and we're gonna put this thing through its paces, and we'll keep you informed about how it performs for us. We're gonna make a few more videos about it. Thanks again, thanks Redodo. Remember, you can get 5% off yours by using the coupon code WILDER. And we'll have a link in the description and a link on our website if you wanna go find it. Those of you who have been following the series may have noticed there's some really interesting cabinet improvements in here. That's because this video is going to come out before that video, but it's really coming together in there. So yeah, keep watching, get subscribed if you're not already, and we'll see you in the next one.